Determine the distance from the point having coordinate 2, 3 to the line given by the equation 2x minus 3y plus 9 equals to 0, measured along a line that makes 45-degree angle with the x-axis. Okay, let us begin. First, we'll try to understand the problem graphically. So here we have a point. Let's consider the point to be A with coordinates 2, 3. Now, we need to have another line which is not going to pass through this line. So let's say we have a line. For simplicity, we're going to let the line cross the x and the y axis in the positive direction. So this is the line L. Fine. And then we will consider another line which is going to pass through this particular point A and also intersect the line L and going to make an angle of 45-degree with the x-axis. So here we have the line L prime. Now L prime passes through the point A and it intersects the line L, let's say at the point B having the coordinates x, y. And also it makes an angle. So this is the angle that it makes, alpha equals to 45-degree with the x-axis. The equation of the line L that is given to us, so that's 2x minus 3y plus 9 equals to 0. Fine. So our goal will be to determine the length AB. So let us denote the length AB with R. So this is the distance between the 2 points A and B. Okay. Now in order to solve this problem, we're going to take the help of the distance form of a line. The distance form of a line states that if we have 2 points with the coordinates x, y, and we have another point whose coordinates are also given x1, y1, and r being the distance between these 2 points, then the distance form of the line is given by x minus x1 divided by, we take cosine of the angle alpha that the line makes with the x-axis. That's going to be equals to y minus y1 divided by sine of angle alpha, and this is going to be equals to the distance between the 2 points. This is referred to as the distance form of a line. The distance form of a line. Fine. Now, to apply the distance form, we'll have to consider one of the line. So, pick up that line which passes through 2 points. Now, clearly that is the line L prime. It passes through the point A and B. So, what we'll do? We'll apply the distance formula to the line L prime. So, here we have 2 points, point A and point B. Now, let's apply the distance form. So, we have the difference of the x coordinates. So, that's going to be x minus 2. Divided by, we have to take the cosine of the angle that the line makes with the x-axis. So we're going to take 45-degree, and that is going to be equals to, now we take the difference of the y coordinates, so we'll have y minus 3 divided by sine of the angle 45-degree, and this is going to be equals to r, where we are assuming r to be equals to AB, and that's the value that we need to obtain. Okay. Now let's rewrite the equation. Now what we can do, we can either take x minus 2 divided by cosine of 45-degree equals to r, or we can take y minus 3 divided by sine 45-degree, and that's going to be also equals to r. Now what we can do, we have 2 equations, and from each of the 2 equations, take the first equation for instance, and from here we can isolate x. So x is going to be equals to 2 added to r times cosine of 45-degree. Now we know cosine 45-degree, that's 1 over square root of 2. So we get 2 plus r over square root of 2. So this is going to be x. And similarly, we can find out y. So y is going to be equals to 3 added to r times sine 45-degree. We know sine 45-degree also has a standard value of 1 over square root of 2, such that y becomes equals to 3 added to r over square root of 2. So here what we have done, we have taken the point B and converted into a parametric form. So here the parameter is r, the distance between the 2 points A and B. So that means here we can write, that means the coordinates of B, coordinates of the point B, which we initially considered to be x, y. So we say that this is also the same as when we express it in the parametric form. That's going to be 2 plus r over square root of 2, and the y coordinate will be 3 plus r over square root of 2. Fine. Now that we have parameterized the point B, so here in the figure we can see that the point B is going to lie on the line 2x minus 3y plus 9 equals to 0. So what we can say? We can say that the point B is going to satisfy the equation of the line. In other words, so what we can do, whatever parametric form of x and y that we obtain, we're going to substitute that in place of x and y in the equation of the line L. Let's do it. So we will get 2 times x. So here x is going to get replaced with 2 plus r over square root of 2 minus 3 times y. The y is going to be 3 plus r over square root of 2 added to 9 equals to 0. So we get a new equation, and once we solve this equation, we'll be able to find out the value of r. So let's do that. First, we distribute 2 with each of the 2 terms within the parentheses. So 2 times 2, that's 4, added to 2 times r over square root of 2 gives us 2r over square root of 2. Then we have negative 3 distributed to 3 plus r over square root of 2. So we get 9 minus 3r over square root of 2 added to 9. And that's going to be equals to 0. So we can cancel out 9. And then we are going to get r over square root of 2. That is going to be equals to 4. So cross multiplying gives us r equals to 4 times square root of 2. So we have obtained the value of r. So here we can say that thus the distance between the 2 points A, B, that's simply going to be equals to 4 over square root of 2 units. That's the final answer.